Okay, some new vocabulary. Let's talk about identities. Addition and multiplication both have identities. Subtraction and division do not. Okay, the additive identity is a number that when you add any number to the identity, you get the same number you started with. Can you think about what that is? Okay, so we take any number and we add the identity to it, and we end up with that same number. What number is it? 0. Yes, 0 is the additive identity. Multiplication also has an identity. It means that when you multiply any number times a certain specific identity, you get the same number that you started with. When you multiply any number times what number? 1. You get the same number you started with. So the additive identity is 0, and the multiplicative identity is 1. Great. Another awesome thing about identities is the way that they work with inverses. So if we take a number, we can add its inverse, and we will come out with the additive identity. What's the inverse of this number? Let's say A is a random number, or maybe we should stick with X. Okay, if we have a random X, what number do we need to add to that X so we can come out with the additive identity? Let's say X is 3. What number do we need to add to 3 so we can come out with the identity 0? You would add negative 3, right? 3 plus negative 3 is 0. 3 and negative 3 are inverses of each other. Okay, so if we have a arbitrary number, any number, we can add its inverse. The inverse of the additive inverse of x is negative x, and you'll come out with the additive identity, which is 0. Multiplication works the same way. You can have a random number, okay, any number, and if you multiply it times its inverse, you'll get the multiplicative identity, which is 1. So again, let's use 3. Let's say 3 times what will give you 1? 3 times what number? 1/3. 3 times 1/3 will give you 1. 1/3 is the multiplicative inverse of 3. They're inverses of each other. So x, any random number x, times 1 over that number, the reciprocal of that number, is going to give you the multiplicative identity, which is 1. Okay, so we have identities, 0 for addition, 1 for multiplication, and we have inverses, negative numbers for addition, and reciprocals for multiplication. Okay, let's talk about 3 properties of addition and multiplication. The first property is called the property of commutativity, or you could say the commutative property. This property is also called the abelian property, where we say that addition is abelian. And it's named after a famous mathematician, okay, Niels Henry Abel. And so we like to call this the abelian property. Okay, but I think Math Excel will probably call it commutativity or the commutative property. So what does this property say? It says that for addition, let's write it out for addition. I'll show you an example down here first. If we say 2 plus 1, that's 3, right? That's the same thing as saying 1 plus 2. It doesn't matter what order you add things in, you're still going to get the same number. Okay, that's the property of the commutative property. If we say A plus B, doesn't matter what order we do it in, that's the same as B plus A. If we have random numbers A and B, any order you can add, doesn't matter. Okay, so I like to think about this as a train, okay? Maybe a train, a commuter train, or a commuter bus, or you could think of a commuter, somebody who commutes to work or commutes to school, you have to go there and you have to come back. So if you think about this as going there, coming back, it's the same thing. All right, so this goes there and then it comes home. So either way you do it. Multiplication, same rule. If you multiply things, you can multiply them in any order. A times B is the same as B times A. Or you might say 2 times 3 is the same as 3 times 2. Same thing, okay? It's equal. Commutativity. The next property is the property of associativity. Associativity is where you have some things that are kind of picky about who they want to hang out with, okay? So let's say if you do 2 plus 3, okay, 2 plus 3 first, and then after that we're going to add 4. Okay, so 2 plus 3 is 5, add to that 4, okay, so you get 9. That's actually the same thing as if you would, rogue parentheses, as if you would first add 3 and 4. 3 and 4 is 7, and then add 2. That's still 9, okay? So associativity tells us we can add things not only in any order we want, but when we have multiple things, not just 2, we can still start where we want to start, okay? So the parentheses don't actually matter. Order of operations would tell us we need to start here on this side, here on this side, but they actually end up being the same thing. So the rule would say A plus B plus C is the same as A plus B plus C. This is the property of associativity. And multiplication has the same property. A times B times C is the same thing as A times B times C. Okay. If you start here or if you start here, doesn't matter, same thing. The way I like to remember this rule is that the A and the C are picky with who they like to associate with, but the B likes to associate with everybody. So notice the B comes over and hangs out with the A a little bit, and then he's hanging out with the C a little bit, but the A and the C, they don't hang out with each other. Okay, let's look at the last property. This is the property of distribution, and instead of being a property just for addition or just for multiplication or for each one separately, the property of distribution is a property of multiplication over addition. So first let's look at an example, and then I'll show you the rule. So an example would be 2 times 3, having some trouble, 3 plus 4. Okay, so order of operations would tell us that we need to add first, so we'll get 7, and then we would multiply, we get 14. What distribution tells us is that we can distribute the 2 over the addition. So this is times right here, this is addition right here. Let me rewrite it. Okay, we can distribute the 2 over into the addition. So then we'd have 2 times 3 and 2 times 4. So 6 plus 8. And 6 plus 8 is 14. So it actually does work out. They are the same. Okay, and in this problem, doing it the order of operations way is much faster. But we will get to some problems with some variables where distribution is going to be essential. Okay, so let me erase this and write the property out. Okay, so if we have A times B plus C, distribution tells us we can distribute this A over the B plus C. Okay, the multiplication can be distributed over the addition, and we get A times B plus A times C. Okay, let's do some examples with this specific distribution property. Let's look at number 8. It says use the distribution property to rewrite this expression. Let me rewrite the distribution property. It was A times B plus C equals A times B plus A times C. So over here we have, notice this, kind of looks like this part. This property and all properties work both ways. So you can distribute the A over the B plus C, but you can also factor out an A in this side and come backwards to over here. So if we have 8R plus 8S, distribution tells us we can factor out the 8's. So it would be like this, 8, then R plus S. Okay, so this is like working backwards. Pull out the 8, and we get this. Notice if we distributed this 8 in, we would be back to where we started. Okay, good. Let's look at number 9. Okay, similar question. Number 9 says simplify by using the distributive property, negative 10 times 3m minus 2n plus 8p. So we're going to distribute this negative 10 over the addition inside this parentheses. Okay, negative 10 will get distributed to all terms. So this term, this term, this term. Okay, every term. So negative 10 times negative 3n. Remember to multiply the coefficients, leave the variables alone. Negative 10 times negative 2n, two negatives, so it's going to be a positive. And then negative 10 times 8p, positive 8p, so negative 80p. Okay, great. Let's look at one more. Number 10. Use the distributive property to rewrite the expression without parentheses. So we have negative 7d minus 8y. Okay, so this time we don't have a number here, but it's like a 1. Okay, it's an invisible 1. Sometimes we don't write the 1 if it's just a 1. So we just have a negative, but we can distribute that negative. So we're going to distribute the negative to every term inside the parentheses. So negative times negative, okay, the two negatives cancel out. We just get 7d. And the same thing here, negative 8y with another negative, so the negatives cancel out. We get positive 8y. All right.